This is Geometry, Semester 2. This is Pythagorean Review. It is a unit, and it is the 10th unit in this Semester 2. And this is lesson number 1, Legs and Hypotenuse Practice. It's on creatormath.com under the Geometry tab. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. You might have to put in creatormath.weebly.com to find the website through Google. First question is, how many legs does a triangle have? So let's just model for you going back. Let's close this. Let's go here. Let's make sure we're in the correct place. So this is creatormath.weebly.com. See it right there. This is what it should look like when you get to the home page. We're going to go to Geometry. We're going to pass by the vocabulary. Get to the table of contents, Semester 2, table of contents. This should have been copied onto your pages 2 through 6 of your composition book a long time ago. If not, do it now. So Pythagorean Review is the name of the unit. Here is the first lesson. It says legs and hypotenuse locations. Here's the page number that these notes go on. It's not really giving me notes for this, so we'll go back and see how to hook those up for you, but that's where you're going to find them. Let's go through and see if we can do the problems without that, and when you look, those notes should be there. So, how many legs does a right triangle have? So, this is 2, just like a human. Let's just go quickly through this. Draw a right triangle. How do I know it's right? Because that square says 90 degrees. And it has a leg here and a leg here. There's a leg, and this side's called the hypotenuse. I guess because it's a review unit that they're going kind of lean on us right here. So, how many hypotenuses does a right triangle have? 1. 1 hypotenuse, 2 legs, that makes up 3 sides. That's all you got in a triangle. The 2 legs of a right triangle are attached to notice how they're attached to the 90-degree angle. That means either adjacent, next to, or attached to the 90-degree angle. So attached to the right angle. Another name for 90-degree angle is right angle, which all of this should be reviewed to you. That's why it's called a review standard. So we'll go a little bit quicker. The hypotenuse is across from the right angle and the longest side. So notice, the 2 legs attached to the 90, across from this 90, opposite this 90 is the word in geometry, is the longest side and the side across from the largest angle, so the hypotenuse. So it's across from the right angle and it's the longest side. Which of the following is the Pythagorean Theorem? Hypotenuse squared equals leg squared plus leg squared, yes. C squared equals A squared plus B squared, yes. A squared plus B squared equals C squared, yes. You should be able to navigate all 3 of those forms of the same equation, which is called the Pythagorean Theorem. So all of the above type thing, right? All of these are the Pythagorean Theorem. So in the following triangle, the x side is. So they're asking us how long is x right here? How long is this side? Well, so let's start with my favorite way to write the Pythagorean theorem, which is hyp squared equals leg squared plus leg squared. Most students learn a squared plus b squared equals c squared, and that's fine. That is valid, but I like to make sure to define the hypotenuse first. So I would even encourage students to say c squared equals a squared plus b squared. But I would say hyp squared equals leg squared plus leg squared. That allows you to understand what goes in for each of those variables in the original Pythagorean theorem. So we have a leg here and a leg here, 2 legs. So these go in for legs. It looks like we've got an x squared, and we have this leg is 12.8 squared, and we have 16 squared. And we're trying to solve for x, so we're going to do some rearranging here. We're going to say minus 12.8 squared. We're going to subtract the whole thing. It's going to disappear from this side. I'm going to reverse the sides, and this is going to become 16 squared minus 12.8 squared. Then we're going to take the square root of the left and the square root of the right, and we're going to get x is, we'll see if we're approximately equal here. This one's definitely a calculator problem. Go to your calculator, turn your calculator sideways so that we get the full functioning calculator, because we're going to need some square roots here. And we're going to type in the whole problem straight away. We're not going to do this in separate pieces. So we're going to clear, say square root, that's the square root here, 16 squared, there we go, minus 12.8 squared. We're going to close this all in parentheses. That means the square root is taking of all that. The square root is over all this here. We get 9.6. And now that I'm looking at, whoops, let me write 9.6. Now that I'm even looking at this, one of the two legs attach the right angle. In the following right triangle, the x side is, oh, I guess I should read directions. That'll solve it right there. The x is one of the legs. So they're really leading us through this. I thought we were ready to do Pythagorean, but no, we're still going on this. All right, let's see. In the following right triangle, the x side is, okay, I got it now. It's the hypotenuse. That's the longest side, and it's across from the largest angle. In the following right triangle, the x side is, again, that's a hypotenuse because it's across from the right angle. It's not touching it, right? The legs touch the right angle, so the hypotenuse. Oh, well, a lot easier than I thought it was. In the following right triangle, the x side is, again, across from the right angle, not touching it. That's the hypotenuse. Interesting, they've rotated it all around for us. I guess they really are testing us. Do we know that the hypotenuse is across, not touching the right angle? So this is the hypotenuse still. They're going to do it one more time. Well, at least it's easy. X is the hypotenuse. It's the longest side. Even it looks the longest, right? In the following triangle, x side is, this is one of the legs because it's attached to the 90. Either of the sides attached to the 90. Both are called legs. One of the two legs attached to the right angle. In the following right triangle, x side is one of the legs because it's attached to the 90. Oh, I can go fast on these. In the following triangle, x side is one of the legs because it's attached to the 90. In the following right triangle, x is one of the legs because it's attached to the 90. In the following x is one of the legs because it's attached to the 90. One of the legs because it's attached to the 90. Across from the 90, this is entirely too many. I may go back and just pair these out. All right, hypotenuse. X is one of the legs. Wow, we really need to know that these are legs. And this is the hypotenuse, okay? That's what we're headed here. This is one of the legs, all right? Let's put it in right there. Probably shows up on the next page. It does. Let's see what this is. In the following, this is still one of the legs attached to the 90. This one's one of the legs attached to the 90. In the following, x is one of the legs because it's attached to the 90. In the following, x is, well, across from the 90, so it is the hypotenuse. You only have two choices here. Is it one of the legs or is it the hypotenuse? X is one of the legs because it's attached to the 90. In the following triangle, the x side is one of the legs because it's attached to the 90. And they even tell you right here, attached to the right angle, right, on every single one. So they're really just going over and making sure we know those different sides. I guess they're going to make us solve the Pythagorean on the next lesson, okay? So this is, just make sure you match up the name, Geometry Semester 2. This is the 10th unit called Pythagorean Review, and it is Legs and Hypotenuse Practice, lesson number 1 on creatormath.com under the Geometry tab.